For today, we'll be running through a quick overview of what we'll be using for hands-on, which is ksqlDB, and then we'll jump into the hands-on as quickly as we can, so that you can get some real, experience with what we're talking about. If you have any questions, feel free to bring them up over the course of the session in the chat, and we'll be happy to answer them there. Right. So before we start, a bit of introduction about ksqlDB itself, what we'll be using for today. So in its most basic essence, ksqlDB is actually what we call a event streaming database. And what it allows you to do is, it allows you to really tap on top of a Kafka topics and streams of events, essentially, and to be able to process them in real time while leveraging a familiar mental model, which is SQL. Especially for anyone who's joining us from the database world, you may be familiar with SQL syntax. But the most important thing in all of this is that it reduces the complexity that you need to build a stream processing application from a number of different distributed components, which involve things like Kafka Connect, getting data into your topics, Kafka itself, as well as the stream processing framework of your choice. There are other frameworks available, but most of them involve handling, managing and scaling a separate set of distributed components. On top of that, serving the needs of both synchronous and asynchronous workflows with pull and push responses or updates as query results are being generated. Now, with ksqlDB, all of that is contained in a single elegant package with just one dependency, which is Kafka. So it allows you to get your data into and out from Kafka. It allows you to process it in real time and to serve both event-driven applications in terms of what we call push queries, as well as your more traditional request response workflows, which is what we would serve using pull queries. For those of you who are familiar with the Kafka ecosystem, ksqlDB is actually built on top of Kafka Streams, which is a native framework that is part of the Kafka ecosystem itself. The main advantage here is that ksql makes it a lot easier to access because you don't necessarily need to know the DSL of Kafka Streams, which is actually Java-based. Now, of course, there is a trade-off here, as you can see on the slide, which is there's a kind of trade-off between the ease of use and the flexibility of the various options. Of course, at the lowest level, you could actually build your own consumer and producer applications and express all of your logic from scratch in the language of your choice. You could make use of the constructs that's available in Kafka Streams, or you could make use of the really easily accessible SQL syntax that's in ksqlDB. If you have familiarity with more than one of these options, you may want to consider looking at our documentation, which talks about which one that you may want to use as a starting point, depending on your requirements and your comfort level with a specific language or a specific option. Right, so without further ado, I'll just quickly cover a couple of concepts around constructs in stream processing, and in ksqlDB in particular, and what some of these transformations would look like, and then we can jump into the hands-on. So there are actually two main data abstractions in ksqlDB when you think about stream processing. The first is naturally a stream, and if you're coming from a Kafka user, if you've used Kafka, if you've written Kafka clients before, this is going to be very familiar to you. The stream is the most familiar form of a Kafka topic. It's a sequence of events that are individually immutable. So when we look at a stream, we are more interested in the kind of patterns over time, the individual events, individual changes that are represented by events in the stream, and the fact that the stream itself is potentially unbounded. Of course, we know that behind the scenes in Kafka, there's a certain retention period on your topics. But as long as producers are producing events into our stream, we have no guarantee on how many events could be in the stream. That's a reflection of your level of activity, and how long we'll be getting events for. That's dependent on what the producers are doing, which ultimately would be some kind of interaction with other applications or with a human user. Right. The second abstraction is something that you may not necessarily be as familiar with, which is a table. Now, if you're coming from the database world, then this is something that you may easily recognize as something that looks a lot like a materialized view. And if you're trying to think from the Kafka point of view, this is essentially what a compacted topic looks like, where unlike a stream, we have a generally well-bounded number of rows that we are interested in. And naturally, when you think about a table, that means there's some concept of keying. There's a key on each individual event, and you can think of it as a sequence of changes for that key. So the table allows you to interpret a Kafka topic as essentially something like a change log, where you're only interested in the latest set of values for each key. In the example on the slide, we only have one non-key column, but you can imagine in production or in reality, your events may have multiple columns. So the whole idea is that by collecting data that's within events that's within a Kafka topic into these two abstractions, how do we actually access them? So that's where, if you recall something that I mentioned very briefly earlier, ksqlDB is actually able to serve two different models of queries. The first is something that's a bit more event-driven, similar to how you would use a Kafka consumer client, where you create a query. In ksqlDB, this is in a SQL-like syntax, so it looks a lot like something you may do on, say, Postgres or SQL Server or something like that. But the key difference is that, unlike in a database, you create the query and it remains running. So if you imagine what happens in a database world, I have a table of data which gets updated every now and then. And then I create a query, and when I fire the query at the table, I get the current state based on whatever's in the table at that point. The opposite happens in the stream processing world. I create a query which sits there on top of a Kafka topic, and as events pass through the topic, the query is applied to them and updated results are emitted. So that's the meaning of the highlighted term, emit changes. So these updates, these results of the query are actually pushed or published towards downstream applications, which end of the day could be any Kafka consumer. So this is the more commonly seen form of a stream processing query. The interesting thing though is that ksqlDB as a stream processor is also able to serve your synchronous, your request response workflows, what you can think of as a pull query. We call it classic here with the quotation marks to highlight the familiarity for folks who may be coming from, for example, the REST-driven kind of world. The idea here is that the query is constantly running as events pass through, but your applications are not necessarily interested in getting every single update. Instead, since this is synchronous, someone comes in and they say, I'd like to know the current state, much like issuing a query against a view. You would then issue a pull query where you go to, in this case, ksqlDB, and you say, I'd like to have this particular columns for this particular key, please. And then you get the result at that point in time. Now, why we highlight this is that this means that with a single stream processing component, ksqlDB, you're able to serve all kinds of application requirements, whether it be event-driven or something that's going to be a bit more synchronous. And it all comes in one elegant package. Right, so having said this, and before we jump into the hands-on, let's look at what you can actually do with a stream processing query in ksqlDB. So you could have filtering. This is relatively straightforward projection. If you look at the animation, what's going to happen is that we have, and this is actually a valid ksqlDB query. We are going to read off a source topic, which we've abstracted as a stream. So this could be a stream of sensor readings. And we say, we potentially want to alert somebody if the reading is high. So maybe this could be something is under high pressure, it's running hot. And we know that our threshold is 41. Again, this could be 41 bar, 41 degrees, whatever. It depends on what your sensor is doing. So what actually happens here is that the dots, the individual events or readings in blue, are the ones where the value satisfies our predicate. In other words, it's higher than 41. The dots in orange are those that are not. So as they pass through the filter, you can see that the blue events are getting allowed and the orange ones are getting dropped. So this is a simple filtering. And this continues running constantly. So we don't show this on the slide, but your sensors could be constantly pushing in new readings, and ksqlDB simply consumes through the entire topic, applies this query, and then pushes these results out to an output topic, which has been transformed from the original. We can also join. This is where we go beyond just working with a single individual stream of input data. We have two streams of data where we want to get a combination of fields of information that's not available in a single stream. So we could say, one is a lookup table, which tells us what brand each individual sensor is. We are continuing the sensor story, by the way. So we have something that tells us what brand each individual sensor is. And as readings come in, we join on a key. In this case, maybe the sensor ID. And what you can see is that the output of the query is actually different from both of the inputs. So it's kind of like a combination of colors. That's why it's going from blue and red to green. And we get something that wasn't available with just a single stream of data. Particularly helpful if, let's say, you just want to add some context to a stream of data that you're receiving, that will then inform you on how to react to it. So you may be doing, after that, routing this alert to a specific team. You could filter based on your enriched fields, where you can say, I'm not interested in maybe brand C. So I'm just going to filter that out. So you can say where brand is not equal to C, for example. So you can see you can start combining different queries together, or rather different functions together in the same query. On top of that, though, because so far we've just been looking at relatively stateless transforms, you can do stateful transformations as well, such as aggregations. So if you're trying to detect patterns over time, trying to detect, for example, thresholds, a certain form of activity, you may be looking at the average, you may be looking at the minimum, at the maximum, at the sum. In this case, we are showing the average. So again, what you see here is actually the results are being updated, and each of these updates is represented by one of these red colored event dots that's moving out of your query. And you can actually see the output in the table representation here changing. So you can imagine anything that's consuming of the changelog on the right, these are consuming of a push query. And if you have your synchronous application, where maybe someone comes in the UI and says, look, I just want to know sensor 1 right now, then that will go to the table and it'll pull, and right now it gets 68.5. If we wait for a couple of seconds, where the average is actually 45, we put it now as 45. We come in a couple of seconds later, it becomes 68.5, and similarly for the other keys. So this is how both push and pull queries work. So that's kind of it for a quick primer on ksql before we jump into our hands-on. But because we are going to be using Confluent Cloud today, we'll be just showing you very quickly all of the features that's available within Confluent Cloud. So you don't just get Kafka, you don't just get ksqlDB, you get all of the features that you see here. And these are beneficial to the various stakeholders in your whole data ecosystem, your developers, operators who keep the platform running, and architects who design around requirements, compliance, compatibility, security, and so on. So if you are interested in learning more about the other features of Confluent Cloud, do let us know, and we'll be happy to reach out to you after the call today. But for now, on to, I guess, what most people would be waiting for, which is our hands-on workshop. So again, if you haven't already done so, please sign up for a Confluent Cloud account. You can use a personal email, and it is free. And if you're signing up for the first time, you actually get credits, which will actually essentially cover anything that we are doing today. Of course, make sure that you shut it down after the call or after the workshop so that you don't incur unnecessary charges. And we'll actually show you how to do that at the end of the session. Also, please join us at the this link for the lab guide. And I actually have this open in another window. So what I'm going to do is I'm going to copy this into the chat. Let's see, here we go. Here's the chat. So ignore the
Kaijun, I think you have to put it in the event chat
okay, where did I
on the
put it?
left-hand side. Yeah. Big
Do you
event.
see it? Yeah. Do you actually
Yeah.
see it? Okay.
Yeah, so I think.
Okay, that's great. So yeah, so go to that link that will bring you to this GitHub page, and we'll be running through this for the rest of the session. So first thing you do, you go to confluent.cloud. Whoops. And that will bring you to this page. Now, if you haven't already signed up, you would have to do that and then catch up. I've already signed up, so I'm just going to put in my email and password. And that would land you up in. I don't want to save my password. Thank you. Okay, so that will land you up in this landing page that we'll see in just a minute. Now, I have a testing environment going on, but if you've just signed up, what you'll see is just the default environment with no clusters. In fact, you'll likely get taken straight to this screen, straight into your environment. So the first thing that you'll need to do is you need to create a cluster. Uh, you don't need to follow the tutorial because we'll actually be running through that as part of the exercise. So depending on where you are in the world, click on create cluster, choose basic. And now the reason that we choose this is that basic clusters actually scale down to 0. So if you don't put any throughput on it, if you don't store any data in this cluster, you're not going to get built for anything. Right, so click on the basic cluster. Choose your provider of choice. There's a very little difference unless you're trying to look for a region that's near to you. I'm in Singapore, so we have a region in Singapore. There we go. And basic clusters only have single zone availability. If you're interested, standard and dedicated clusters actually offer multi-zone high availability, so you can always explore that. Right, you can give the cluster a name, or if you really just want to speed through this, you can actually ignore the name altogether. And you'll get a quick summary of your usage limits. Of course, standard clusters have slightly lower limits, but they will be enough for our hands-on for today. So just click on launch cluster, and in very short order, we would have a cluster running and ready for use. So if anyone joining us today has ever tried or is currently either deploying or operating a Kafka cluster, you can probably appreciate the ease of getting a cluster on demand just like that. And of course, if you're done with it, you can actually delete it very easily, which I'll show you at the end of the hands-on. Right, so next thing we are going to do, we are going to create a ksqlDB application. So ksql actually runs on its own separate set of workers apart from the brokers, which allows you to manage performance and resource usage separately. And in Confluent Cloud, it's actually available fully managed as well. So it's as simple as going here and saying, I'd like to create a ksqlDB application, please. And what you're going to do is that you're going to want to select global access. Now, for today, we are not going to run through all of these granular access control and security features, but just keep in mind that if you need to, and in fact, we recommend this for production, you can actually granularly limit the access to resources in your cluster. So we're not going to do that for today. We're just going to choose global access. And you can actually choose a cluster size. So if you really want to be efficient on cost, you can actually choose to go with a cluster size of one stream processing unit. This is actually just a logical unit that represents how much throughput and how much load you can place on the cluster. For today, we aren't going to be placing a large amount of load. That's why I'm just going to go in with one. And now that's going to take a little time to provision because the worker needs to spin up and then it'll tell you that it's ready. So while doing that, we are going to actually run through creating the topics that we are going to use for today. Now, if you click on the dashboard, you'll realize you don't see the same kind of graphs that you see in the lab manual, and that's mainly because we don't have any data that's running through the cluster right now. But you can imagine if you did, you can actually have a look at your production, your consumption, resource usage, and all of the other relevant metrics for Kafka. For today, what we're going to start with doing is that we're going to actually create a topic. So you'll want to follow this naming and the number of partitions here. We're going to be creating a users topic and a stocks topic. This is ready for us to actually generate data into right after this. So at the most basic level, you can just come in and you can choose the topic name and partitions. And if you want to fiddle with the other topic configurations, you can do so. You can see, for example, we can create a compacted topic if we want to. And there's retention time and size that you may be familiar with. Do keep in mind that in Confluent Cloud, because this is a managed service, to be able to deliver the SLAs that we promise, there are some configurations that are going to be locked, as you can see here. But again, we won't be going too deep into those for today. That's not really the focus. Right, so I've got my users topic and I'm going to create a stocks. There we go. Yeah, stocks topic. And much like the cluster itself, because it's already running, I create the topic and it's going to be there. It's going to be empty, not doing anything in particular. But later on, once we have data flowing through it, the topic, we can actually come back here, look at the metrics, look at the messages themselves. We can explore the configuration. We can edit and delete the topic. If there were schemas, we would see those. We won't actually use schemas today, just FYI. Right. So now we are about to create a connector. So if you are familiar with the Confluent ecosystem, you'll know we have a data gen connector. It's essentially a data generator. It's really helpful for things like this, where we just want some simulated data to run queries on and to see how ksqlDB works. But to get a connector running, we'll actually need an API key and secret for it. So let's do that right now. So if you look under data integration, you'll actually see there are places where you can get guides for setting up producers and consumers as well as connectors. But of course, to do any of that, you need to authenticate yourself to the cluster. So you'll need an API key and secret. You'll see one that's already existing for the ksqlDB cluster we created. We'll want another one. This is for our connector. So you want to do one of two things, either copy at least the secret, or you want to download it. So let's just give that a description. I'm going to download this. You can choose to do so as well. And of course, don't bother stealing my API key because I'm going to delete it right after the workshop. Right, so once the API key is ready, then we can actually create our source connectors, our data generators. So you click on connectors and search for data gen. Right, I'm just going to come in here and see, is there anyone who's really having challenges? I don't think so. Right, so back to our hands-on then. So a source connector is actually something that takes data from an external system. In this case, it's a data generator. So that's pretending to be an external system. And it's going to put it on a Kafka topic. So you're going to need to choose where that goes. So let's say we're going to put this on users first. So we're going to be creating data gen connectors for users as well as for stocks. These have quick starts in them that actually produce data of a certain schema and format, so we can just use those. So let's do the one for users first. We're going to use an existing API key, which already lost the secret of. Okay, let's just copy that from here. So put in your API key and secret, and choose the user's quick start. And we are going to be using JSON for today. So you'll also want to set the maximum interval and the tasks. And how you do that is you click on Advanced Configurations, and you set this to 1 second or 1000 milliseconds, as it says in the manual. And you choose just one task. Now, with many other connectors, you can get better parallelism with multiple tasks, but since this is just a simple generator, we don't need that. So we are going to get that started. You can actually review the JSON configuration if you want. I'm going to change this to say users, and I'm going to launch. Now this is going to get connect worker started and start the connector itself. So while waiting for that to happen, we can actually get our next data generator started. So let's do that. Again, use the existing API key and secret. Oh. And now we are going to be doing the stocks, which is actually this one. Still JSON, and still 1 second between messages. Right, so if you really need to figure out which quick start and whether you're using the right one, you can actually look here. Quick start stocks. Okay, I might actually have got the wrong one. Whoops. Okay, go back. Okay, no, that's actually the right one. Okay, we need to update the manual. My apologies for that. Okay, so let's just get this started. And you may have noticed earlier I got a little alert saying that the data gen connector, the users one, is already running. ksqlDB is still provisioning. That's unfortunate. We'll need to wait a while for that. And we also need to wait for this connector to come online. So, but while that happens, we can actually have a quick look at what's happening in the users topic right here. So you can see we're just getting a bunch of generated data in. You can actually pause it and examine it. It's just a few fields on user ID, gender, and all of that. And we'll see one for stocks as well once that comes up. Right. And we'll want to create streams and tables as well. So we've already talked about what streams and tables are. So at this point, it's really a matter of waiting for everything to come online, which should not take too long, hopefully. Right. Okay, so the connector is running, but ksql is not. That's annoying. Nonetheless, we can look at our stocks topic first. And you can actually see we've got a user ID and we've got a number of other fields in here. So you can probably imagine what we are about to try to do, which is we are going to be looking at some of this, what we can do with these two separate streams of data. Right, so now we are kind of waiting for ksql to be ready. By the way, if anyone else who's doing the hands-on already has ksql running, do feel free to jump ahead in the exercises. You can actually see you can copy the entire query that we are doing here. So what you're doing is that you're telling ksql to read a specific topic into a stream. And this is a metadata operation. If you realize what you're doing is that you're telling ksql what the individual fields mean. You're telling it where to get its data from and what format it is in. Now, JSON, plain JSON is not a structured format, which is why you need to provide the entire schema here manually. And once you do that, you'll actually get a stream setup and you'll be able to look at that. Yeah, it's still provisioning. I should probably have provisioned this in advance, but anyway, where were we? Right. So after you create the stream, you can actually start querying it. Where you can see, because it's a stream, you'll actually need to provide the emit changes kind of statement, which basically says that I'd like to read everything. That's what the asterisk means. I like everything from this stream and I like every change as it comes in. And you'll see the same thing, except now you can see that when we specified the structure of the message earlier, that allows ksql to identify what all these columns are, and it arranges it. It arranges all these columns for us. Right. I don't see any questions, so continuing on. Right, still provisioning. Okay, I'll just go through the manual then. So once you're done with querying the data, there would be a stop button on your UI that you can click stop to stop the query. And you'll actually replace your whole query each time. This time round, we are going to take our other topic, which is users. And we are going to tell ksqlDB to read this as a change log, so as a table. And if you recall, what that means is that we are actually going to specify a key. So unlike a stream, a table does require you to specify a key because that tells us how to actually group the data up. And when we've done that, we can actually view the users table, much like a stream. Now, if you don't see any data coming in, it's because we only generate one event per second. So you'll need to wait a second or so for something to come in. Or you can always change the auto offset reset to actually go back to the start of the stream. And that's what you would, and then you'll be able to see everything from the start. Right, so my application is finally up. So I'm going to very quickly catch up by copying and pasting all the queries here. So this is what you should have seen if you had run your queries. When we do metadata operations, what you're going to get is essentially a reply saying that your operation has succeeded and the stream has been created. So I'm going to do that for the table as well. And going to run that. You can actually see table users created successful. This is the query property, auto offset reset, that I talked about earlier. Let's get this out of the way. And if we run a simple select query with latest, you can actually see that it takes a while to actually get new data that comes in because it's like once a second. And there we go. So you get new data coming in once a second. And if we want to get everything from the start, we set that to earliest and we simply run this. It's going to take a while to load, but you can actually see we then get a whole large set of data that comes in. I'm going to stop this. And we're going to actually start looking at creating an actual query. So far we've only done metadata operations. So the difference between a metadata operation and a query is that we have the select statement. So what we are going to be doing now is that we are going to be joining the two streams of data. If you recall what I mentioned earlier, this is when neither stream of data contains everything that we need. So you can see we would like, for example, the site, the quantity, the symbol, these are only in the SOC stream, whereas the region ID, the gender is only in our user stream. So we are going to join the two together, and we are going to get all of these columns in a single stream. So let's do that. And again, because this is a persistent query operation, you're going to get a response message that hopefully says that your query has succeeded. Persistent queries will actually have a query ID, which you can look at on top. So you can see we've created a stock stream. We've created the enrich stock stream using our persistent query. We have one table of users, and we have the persistent query that we've just created. And you see, it literally says create a stream stocks enrich. So that's why we have two streams here, the raw one and the enrich one. Right, so let's just select some data from it and see what happens. Here's a quick tip, by the way. If you want to not have your UI blowout, you can actually limit the number of results you get. Let's say if you're just doing development and you just want to explore what's happening, you can see it emits 5 results and then it stops. And if I run it again, it's going to emit another 5 results and it's going to stop, and so on and so forth. So we could view this in the document view, where we can see the combine all of the fields that come from two separate streams of data. We can view it in the table view, which is what you see in your lab manual. So if you then look at the topic, you can actually see that if there's no topic and you're creating a persistent query, ksql will actually automatically create the output topic for you. So let's look at what that means in the topics window, where you can see this front string is actually the identifier of our ksqlDB cluster. And then you can actually see the same messages running through this as you would see in a select query that you run in ksqlDB, for example. We can also see what's happening based on this consumers, because at the end of the day, a streams processor like ksqlDB is simply consuming off one topic or more and producing to another topic. And we can actually have a look at it right here, where we can actually see all of our consumers for our persistent queries. So if we look at this, we can actually see that it is consuming off stocks and users, and it's pretty much consuming at a good rate. Right, so very quickly, let's wrap up by aggregating some of this data. So earlier we've done joining. So now we are going to do the other two functions that we showed, which is projection, in this case filtering, and an aggregation in one. So the whole idea here is that you don't necessarily need to do this step by step. You can combine the functions. So let's go back to ksqlDB editor and paste in this query. And we would get, again, we expect to see a success message. And if we look at this, we are saying create a table. So now we have two persistent queries that we've created and a new table, which is the number of times a stock has been bought. And if we click on the query button, we can actually jump straight here. It will actually run a query for us. And you can see that over time, the number of stocks bought will be updating. So let's actually pause it right here. So you can actually see that the number changes for a symbol over time. And that's really the persistent query pushing out updated results. Right. So the All right, I could have actually shown that in table view. Let's do that again. Let's query this and let's do it in table form. Yeah, so at this point, we can actually see it when each new purchase event comes in, this table will get updated. So you can see that new rows are being shoved on top right here. It goes from 9 to 10 and then to 11 and so on and so forth. So if you had a push query subscriber, it will be getting every single one of these updates. If you had a pull query, that will actually be something that we could create much like this. This is actually a pull query. So lastly, we'll do a quick showing of a kind of fraud detection use case where we are going to do a combination of time windowing and then alerting based on that. So among the aggregations we have the ability to actually aggregate over a time window. There's several different kinds of time windows. There are tumbling, hopping, and session windows. So tumbling windows are non-overlapping, hopping windows do overlap, and session windows are actually based on periods of inactivity as opposed to just event time. So we're going to create a 5-minute window of the total number of stocks that's being bought, and we are going to actually create a lookup table of accounts to monitor. So there's quite a few things going on in this query. Is we are converting the window start and window end of our time window from the previous query into a string, and we are actually going to group it by the account. So we run that, we can actually have a look at the table, and if we look at the accounts to monitor, okay, I'm going to give that a moment to load. And apparently it's not getting anything new. Let's try it alias. Right. Nothing new. There we go. All right. So what is this query actually doing? So it's doing a couple of things, and let's look at our persistent queries to understand that. So the first thing that we are doing is that we are actually basically windowing up. Where is that? Stocks purchased today. So we are windowing up in a 5-minute window how many stocks have been purchased, and then we want to identify out of these windows how many of them have actually exceeded a count of 10. So this is just an imaginary rule where we say that we want to identify high frequency accounts. So we set more than 10 as our threshold. And we can actually have synchronous workflows where at this point you'll probably have someone involved who actually comes in to say, okay, I know that I have all these stream processing queries, preparing all this data for me in real time. But for now, maybe I just want to run a report. I come in through some web service, some other UI, and that web service would be sending a pull query to ksqlDB via an API. But today we are going to do it using the UI since we don't have a web service ready for us. To do this, you will need to set an additional table property, which is pull table scan enable. This allows us to scan the entire ksqlDB table for to perform pull queries. So let's set that to true. I don't think it's not alphabetized. And we can actually start pulling it from here. And this would be a single point in time query where in this case we don't have anything. So let's drop the number a little to say 20. And there you go. We can see a whole chunk of results that's being emitted. So we can see there's a few different quantities here. And if I modify my pool query a little, and I say I just want the ones more than 80, we'll expect the last two to disappear. And that's exactly what has happened. But at the same time, you can see that the number has increased while we were speaking. So we just keep repeatedly running this, and you can see this is the whole point of a pool query. Depending on the point in time that you run it, the result changes. Now, if you want to compare that with what a pool query does, you can actually say, you can actually simply add on emit changes to this. It will complete and add. And that's going to keep updating it. You can see it goes to 125, 12. Okay, that's not actually the same one. But there we go. So now we have updates coming in. It went from 129, 130, and so on. So that's the difference between a pull and a push query. All right. So that brings us to cleaning up. So I promised earlier that I'll show everyone how to clean up. And we are going to do this by going into step by step. We are going to need to delete the application first, which is ksqlDB. So we just hit delete, put in the cluster name right here. And you can see that your application gets deleted really quickly. Next thing we do, we clean up our connectors. So that is under data integration connectors. If we click on each of them, we can actually delete. Again, we'll need to copy the name in. And as you can see, deletion is relatively quick because, to be fair to users, we don't want to keep billing you unnecessarily once you've expressed that you want to delete resources. So now that everything is gone, we can come in and we can say delete the entire cluster. So if we do that, we put in the cluster name, everything will be deleted. Right. But maybe as a quick bonus content, if you're interested to see what our data was actually flowing through earlier, you can actually click on the stream lineage. And you can actually see that we have data that's being generated into topics. We have a join, we have our various aggregation queries. We also have our UI that we were using to consume directly from the topic. So you can see that here. And the whole point of stream lineage is that it allows you to track changes to your data as it passes through your pipeline. So if this is something that interests you, again, feel free to reach out to us and we'll be happy to go further with you on this. Right, so with that said, I'm actually going to delete the cluster. And I'm going to stop the share because this looks like Inception. All right, so thanks everyone. I think that brings us to our scheduled time for today. So thank you everyone for joining us and have a good day. I hope that you found the session useful and feel free to reach out to us if you have any additional questions.